Assalamu alaikum. Hope you are doing fine. We have learned about the anti-gravity generator, which produces large electric potential used for the acceleration of charged particles. In this video, we are going to learn about a device that accelerates charged particle to gain high kinetic energy. The name of the device is nothing but cyclotron. Let me repeat once again. Cyclotron is a device which accelerates charged particles. To gain large kinetic energy. How it is achieved? How it increases the kinetic energy of a charged particle? Let me tell you. We know kinetic energy is nothing but expressed as half mv square. Here m is the mass of the object and v is the velocity with which the object is moving. Here m remains same, it is a constant, and this number is also a constant. So this term is a constant in the expression of kinetic energy, whereas velocity may vary. So simply we can say that kinetic energy depends on the velocity of the object. Well, so here I get the expressions something like this. Kinetic energy, I take this as the constant. This constant. Here we have v square. So when we combine equal to with the constant, what do we get is nothing but this. Kinetic energy is directly proportional to v square. So this clearly shows that when the velocity of an object increases, the kinetic energy will increase because they are proportional to each other. Okay, here kinetic energy is proportional to the square of the velocity of moving object here. So when we increase the velocity of an object, the kinetic energy increases. This is what done in cyclotron. In cyclotron, we increase the velocity of charged particle. By doing so, the kinetic energy increases. Here, whenever we vary the velocity, we use the term acceleration. We call it as acceleration. The variation of velocity with time is referred as acceleration. So, in a cyclotron, we accelerate charged particle, which results in the increase of kinetic energy. You remember this. Now, how it works? Cyclotron works on the principle of we have learned that whenever a charged particle moves in magnetic field, it experiences a force. We call that force as Lorentz force. It's otherwise known as magnetic Lorentz force. When the charged particle move perpendicular to the magnetic field, it experiences Lorentz force, and that Lorentz force makes the charged particle to move in circular path. So simply we can say the Lorentz force provides centripetal force, because of which the charged particle starts moving in circular path. So when the charged particle move perpendicular to a uniform magnetic field, it experiences Lorentz force and it starts moving in circular path. It is the principle behind the working of cyclotron. Right? What is that? When a charged particle move in a perpendicular magnetic field. Magnetic field. Yeah, when I say magnetic field, it is nothing but a uniform magnetic field. Uniform magnetic field. It experiences magnetic Lorentz force. In short, I write it as MLF. Stands for magnetic Lorentz force. And this magnetic Lorentz force makes the charged particle to move in circular path. This is the principle behind the working of cyclotron. Now, how the cyclotron look like? Let me show this to you. A cyclotron consists of two semicircular containers which is completely hollow from inside. Consists of two semicircular containers. Two semicircular metal containers. This is completely hollow. Okay. Here. Write something like this. Okay. Yeah. Here it consists of two semicircular containers which are separated by a small gap. Okay, and these containers, semicircular containers, are placed in uniform magnetic field produced by an produced by an electromagnet. Okay. Here, this is one pole of the electromagnet. This is the north pole. Then the south pole is present here. At the bottom, this is the south pole of the electromagnet which produces uniform magnetic field. Clear? Now, there's one more thing. These two semicircular metal containers are attached to a high frequency oscillator. This high frequency oscillator. This high frequency oscillator actually produces alternating electric potential. So it produces high frequency alternating electric potential. Okay. So this end negative, remember this positive side. Okay. What does it mean? That I will explain you later. Okay. And here I told you these two metal containers are separated by a small gap. This a gap present between these two metal containers. Now, at this gap, the source of ion or source of charge is placed here in this gap between these two metal containers. Now, if you look at these metal containers, they appear like a letter D. No, they appear like letter D. So, they are named as D. Now, these metal containers are known as D. This is a D, is another D. So, there are two D's are present in cyclotron called as D1. This one is a D1 and this one is named as D2. So, we have two D's. These two D's are enclosed in an evacuated chamber. So, remember this. These two D's are enclosed in evacuated chamber. Evacuated means which is free from air, which has got vacuum inside. Alright. This is the construction of cyclotron. I repeat once again. A cyclotron consists of two semicircular hollow containers enclosed in an evacuated chamber. They appear like a letter D, so they are called as D's. These two D's are separated by a small gap. In that gap, we place the source. Source, this is placed in the gap. This is the source of charged particle or ion. Then these two D's are placed in the uniform magnetic field produced by electromagnet. So are electromagnets. North pole of electromagnet, this south pole of electromagnet. I'll go ahead. Now let me tell you how this device works. Okay. As I told you, here S is the source of charged particle or ion, which is accelerated here. Okay, whatever charged particle we need to accelerate is placed here in this gap. Suppose I have a source of positive ion, a source of positive charge. Positive charge particles are placed here at the this gap. Then what will happen? I told you earlier, this is a high frequency oscillator. Now, the work of this high frequency oscillator is to change the polarity of these D's. Now, if suppose D2 is at a positive potential, means this D1 will be at a negative potential at any instant. Then what it will do? It will alter the potential, the polarity of the D's. When it is positive, it will become negative. When it is negative, it will become positive. When it becomes positive, it will become negative. Like that, it alters. It keeps on alternating the potentials of these D's. That's the work of the oscillator. I hope I have understood. Now, at any instant, if D1 is at a negative potential, that is why I have mentioned here as negative. That negative potential. Here we have a source of positive ion. So what will happen? This positive ions will get attracted towards D1. Okay, we know opposite charges attract and the same charges repel. So because of opposite charge, these ions, positive ions, get attracted towards D1. Okay, they just move like this. They move this manner. When it moves, when the charged particle, when the ion move in uniform magnetic field, it experiences Lorentz force. As the magnetic field is uniform and the charged particle moves perpendicular to it, so it starts moving in circular path. See, it moves this way. It traces circular path. Explain this in detail. There is a positive charge present here. This positively charged particle gets attracted by this D, which have negative charge, which have negative potential. So it moves perpendicular to uniform magnetic field. So it experiences Lorentz force and traces a circular path. When it reaches this gap, by that instant, the oscillator changes the polarity. It becomes it gets a negative potential and it gets the positive potential. If it is so, then this moving charge particle will get attracted towards a D2 further. Okay, then when it reaches this gap again, in that case, what happened? D1 gets a negative potential and this becomes positive the charge. Okay, this gets a positive potential. So again this positive ion which is present in the gap gets attracted towards D1. This is how every time the polarity changes, due to the change in the polarity, the movement of the charged particle or ion continues. So every time it does so, the diameter of the circular path increases. At one point what happened? It comes very close to the edge of the D's. At that point, with the help of a deflector plate, this is a deflector plate. The help of deflector plate, the charged particle which have gained high velocity are removed out and they are made to hit the target. Clear? This is what I will. Okay. Now, with what velocity do these particles travel within the cyclotron? Let's find out that. Now here, due to the motion of this charged particle, they experiences magnetic Lorentz force. This is the expression for magnetic Lorentz force. The magnitude of magnetic Lorentz force experienced by the moving charged particle in the cyclotron. This provides centripetal force. Okay, this provides centripetal force. So I take this one to be equal to centripetal force. The expression for centripetal force is mv square upon r. This is the magnitude of Lorentz force. This is the expression of a centripetal force. These two are equal. Actually, Lorentz force provides centripetal force. So the particles move in circular path. Now, in this equation, the similar terms get cancelled. V and V get cancelled. And what we obtain is nothing but this BQ equals to mv upon r. This is what we get. Now, I will cross multiply this to get the expression for r. Okay, let's say this is r. I take r that side, so BQ will come down. I get mv upon BQ. Fine. I box this. This provide me the expression for a radius. So the radius of the circular path can be obtained with the help of this equation number 1. Okay. Now from this one can also get the expression for velocity just by cross multiplication. Clear? Let me show that to you how it is obtained. And okay, let me show that from equation number 1. And cross multiply. I keep what we decide and remain terms are brought here. So what I will get? V is kept here. Now BQ is taken to left hand side, so it will multiply R B Q. Now M is taken the left hand side, so it will divide by M. This is the expression for V. Yeah, box this. And then this is equation number 2. Okay. Now, if you look at the equation number 1, you will find that it has got 4 terms: M, V, B and Q on the right hand side. What do you understand from this? Here in this 4 terms, M stands for mass of the charged particle. V is the velocity of the charged particle. Then B is the magnetic field, and Q is the magnitude of the charge carried by the ion or charged particle. Okay. Now among these 4 parameters, mass, magnetic field and charge Q are constant. They do not vary. The only term which vary here is nothing but velocity. So we can say from here, we can say that, I write it as such for better understanding, mv upon bq. Here m, b and q, these terms are constant terms. So this can be written as, this equation can be written as R equals to constant multiplied with V. We know when the equal to sign is combined with constant, we get the proportionality. So this equation is written as, I take R as such, then in the place of these two I write a proportionality. R is directly proportional to V. So what does it mean? What does it show? It shows that when the velocity of the charged particle increases, the radius of the circular path will also increase. This is what it means. Okay. So it is obvious from the diagram. When the velocity of the charged particle increases, the radius of the circular path also increases. So it traces a spiral path. Okay. By tracing this spiral path, when it reaches the edge of the D, it is ejected out with the help of a deflector plate. Okay. And made to hit the target. This is how the charged particles or ions are accelerated in cyclotron and made to hit the target. Okay. Next, when we talk about the cyclotron, when we discuss the operation of cyclotron, we must know an important condition called as resonance condition. We must know resonance condition. What is that? There is a condition for resonance to occur. Resonance occurs when the frequency of the oscillator, which is a constant, matches with the frequency of the moving charged particle in a circular path. Let me write this here. Well, the frequency of oscillator becomes equal to the frequency of charged particle under motion, then resonance occur. Now, I will get the expression for the oscillation of, the frequency of oscillator. Okay, for that, I use the expression for velocity. We know velocity is the rate of change of a displacement. When a displacement is divided by time, we get a velocity. Here, time stands for time period in our case. Okay, we know the charged particles move in circular path. So the displacement covered is given by the circumference of the circular path. Circumference of the circular path is given by 2 pi r. This is the formula of circumference. And time or time period is the given letter t. What is this time or time period? Time period is nothing but the time taken by the charged particle to complete one circulation. Time taken by the charged particle to complete one circulation is referred as time period. Yeah, from this, t value can be obtained if we cross multiply. So before doing so, I write this in this manner. Then I take a v for velocity. This is written as 2 pi r upon t. Now if I cross multiply, I will get the expression for t. Time period. T can be obtained. So here I have taken t, the left hand side. Then v will go to the denominator. So 2 pi r upon v. This is equation number. This is taken as equation number 3. Now I substitute r value from 1. So 1 is substituted in equation number 3. So what I'll get? I'll get this. 2 pi upon v. In the place of r, I write this value. mv upon dq. Here, this v and this v will cancel. And get the expression for t. This is for t equals to 2 pi m upon b cube. I box this. This is the expression for time period. I take this one as equation number 4. Equation number 4 provides us the time period. Okay. Then from this, frequency of oscillator can be obtained if we take the reciprocal of this. We know f is the reciprocal of time period. So from this, frequency of oscillation because of this electric oscillator can be obtained if we take the reciprocal. So if we do so, BQ will go to numerator and 2 pi m will come to denominator. I box this. This gives me the frequency of oscillator. Okay. Now I'll find out the kinetic energy of the charged particle in the cyclotron. For that, I'm going to use this expression. Okay, we know kinetic energy is equal to half mv square. We know the value of v. So it is given here. There is equation number 2, but I'm going to substitute here. Now from equation number 2, I get this kinetic energy 1 by 2 multiplied with m. The value of v is R B Q divided by m whole square. Okay, so what do you get? You get this R m R square B square Q square. I square all the terms present within the bracket, then m square. Okay, here the similar terms get cancelled. M and m get cancelled. Remaining terms remains as such. So this provides us the expression for kinetic energy that I write here for better visibility. So kinetic energy equal to half R square B square Q square upon m. This equation gives us the kinetic energy gained by the charged particle in the cyclotron. Okay, so this is the construction and working of the cyclotron. Now let me tell you few limitations of cyclotron. In a cyclotron, we cannot accelerate the particles which do not have charge. Second, electrons cannot be accelerated in a cyclotron. Third thing, in a cyclotron, the speed of the particle is limited. The velocity of the particle is limited. Okay. So these are some of the limitations of cyclotron. I hope the video is useful. If you have any kind of doubt related to the topic, then put your questions in the comment section. Thanks for watching.